Now we talk about curve sketching characteristics. Here we have some definitions that will be used in sketching the curves. For now, we have the relative maximum and minimum. The relative maximum value f of a if f of a is greater than or equal to f of x for all x in the interval. This means we say f of a is called the relative maximum if f of a to be greater than or equal to f of x for all x in the given interval. Here, if you have given an interval and f of a to be greater than or equal to f of x for all x in the interval, we say f of a is the relative maximum. And for the relative minimum, we say f of a is the relative minimum if f of a is less than or equal to f of x for all x in the interval. That means if we have given an interval and a belongs to the interval, we say f of a is called the relative minimum if f of a is less than or equal to f of x for all x in the given interval. And now we have absolute maximum and minimum. It's different from relative maximum and minimum. Here we say f of a is called the absolute maximum if f of a is greater than or equal to f of x for all x in the domain. That means for all x in the domain, f a to be in the domain and f of a be greater than or equal to f of x for all x in the domain, we say f of a is called the absolute maximum. And for the absolute minimum, we say f of a is called the absolute minimum if f of a is less than or equal to f of x for all x in the domain. Here, for all x in the domain or for all points in the domain, f a to be a point in the domain and f of a be less than or equal to f of x for all other points. Here x is the points in the domain. That means if f of a is less than or equal to f of x for all x in the domain, then f of a is called the absolute minimum. And critical value and critical point also. Here, if either f of a is 0 or f of a doesn't exist, then x is a is called the critical value for f. Here, when we find the critical point, we just equal the derivative of the function to 0. Here, if the derivative of the function at a point a to be 0, or if the derivative of the function doesn't exist at the point a, then we say x equals to a is called the critical value for f. That means a is the critical value for f if f prime equals to 0 or f prime doesn't exist. And if a is critical value, then the point a and f of a is called the critical point of f. So here, this point is called the critical point. A is the critical value and f of a also. This point is called the critical point. For the criteria for increasing and decreasing function, we let f to be differentiable on the interval ab. That means if f is differentiable at this interval, we say if f prime of x is greater than 0 for all x in the interval ab, then f is increasing on this interval. That means if the differentiation of the function is greater than 0 or if it is positive in an interval ab, then we say the function f is increasing at the given interval. Here AB is the given interval. And if the derivative of the function is less than 0 for all x in the interval AB, that means for all points in this interval, if the derivative of the function is negative or less than 0, then we say the function f is a decreasing function on the interval AB. Here AB is arranged from A until B. Okay, these 2 points is about increasing and decreasing of a function in the interval AB. Now we have the definition of concavity. For f to be a differentiable function on the interval AB, we say f is said to be concave up on AB if f prime is increasing on AB. Here, look, in the previous slide, when we talked about increasing and decreasing, we said f is increasing or decreasing. But here for concave up and concave down, as I will talk about later, for concave up, we talk about f prime. Okay, for the function of f prime, if this function is increasing on this interval, we say the function f is concave up. And for concave down, we say the function f is said to be concave down on this interval AB. If the derivative of the function is decreasing on AB. Okay, here, if the derivative of the function is decreasing on this interval, we say the function f is concave down. And this is inflection point definition. For the inflection point, we say a function f is or has inflection point at A. If and only if f is continuous at A. Here we say if the function is continuous at A and f changes concavity at A. That means if the left hand side and right hand side concavity are different. For example, if the left hand side of the point A is concave up and the right hand side is concave down, then we say the function f has inflection point at the point A. Okay, this is the definition of inflection. We have first derivative of slope or gradient. Here, if the first derivative is greater than 0, then the gradient or slope is positive. And the graph is like this. Okay, it's increasing. Look, as we talked about before, we said if the first derivative is greater than 0 at an interval, then the graph is increasing. Look, and also the gradient or slope is positive. And if the first derivative of the function is less than 0, then the gradient or slope is negative and the graph is like this. Okay, it's decreasing. And if the derivative of the function is 0, then it's a horizontal. Okay, and the gradient or slope is 0. Okay, and for the second derivative, f dot prime at point C, we talk about concavity. Okay, here we use the second derivative for testing the concavity of the function. Here we say if f dot prime of x is greater than 0, then the graph is concave up. Look, it is concave up if the second derivative of the function is greater than 0. And if the second derivative of the function is negative or less than 0, then the graph is concave down. And if the prime is 0, we may have an inflection point. And now we have these three types of graphs, which the derivatives of the functions at point A is undefined or is not defined. Here, if you have a corner at point A, look here, at this point we have a corner. So at this point, at point A, the function or the derivative of the function is undefined. Or you can say the function is not differentiable at point A. And in the other case, if you have a vertical tangent at point A, look, at this point, we can have a vertical tangent. So at this point, at point A, we say the derivative of the function is undefined. And also, in this case, if the graph of the function is discontinuous at a point A here, or if it breaks at A, look, if you look at the graph, it's discontinuous at point A. So you say the derivative of the function f of x is not defined at point A. We have these three cases that the derivative of function is undefined at a point. And for curve sketching, we should follow these steps. Let f of x to be y. Here, we should have given a function. Let's say f of x. In step 1, we should find f prime of x and set f prime of x to be 0 to find the critical point. That means here in step 1, we just find the critical points of the function by equaling the first derivative of the function to 0 and then finding the values of x, and after that we put the values of x into the function to get the critical points as we did before. And in step 2, we should find the second derivative of the function and then identify the maximum and minimum point. That means the points that we found before in step 1, we just determine them to be maximum or minimum points. Okay, by putting those points that we obtained in step 1 into step 2, I mean into the second derivative of the function, to identify the maximum and minimum points. And in step 3, we just identify the intervals. In this step, we find the increasing and decreasing intervals. Okay, in step 3, we just find the increasing and decreasing intervals. In step 4, we just create the sign table for f of x, f prime of x, and f double prime of x. For the points that we found here in the first step, we put all into a table, and then we are going to find the sign of each of these functions, f, f prime, and f double prime, in the intervals that we obtain. Okay, and look here, we have a note. If the left and right sides of a point has different signs for f double prime of x, we say the function is an inflection. The point is an inflection point. And in step 5, we find the inflection points. To find the inflection points, we just should find the second derivative and equal it to 0, then find the values of x. And in step 6, we just sketch the graph by representing all of those points that we obtained in the previous 5 steps. We represent all of those points into the xy plane, then joining those points we get the graph. And it's enough for this week. For the next week, We will try some examples to in curve sketching.